All right. Okay, let's go over, I guess, let's do the homework first.
Okay.
And then kind of talk about the quiz a little bit, and then we'll get into the packets and some other review problems that we'll do. So a big part of the quiz on tomorrow is going to be the theorems and all those repercussions, questions you can ask about. So you got to state the theorems, and then there's questions about them. Like we've been having, and does a conclusion hold, and true and false, and all that kind of stuff. The extreme value theorem is one we have to state. Again, extreme value means max and min. Has both a max and min. Intermediate, kind of think between, so that's the one about hits all the points in between the endpoints, F of A, F of B. And then, of course, we have the mean value theorem. Now, when you have the mean value theorem, basically mean meaning average, it basically says that whatever the average rate of change on this interval is, there has to be some place that has the same instantaneous rate of change, the derivative. And, of course, continuous on the closed interval, and we add in this piece that it's differentiable on the open interval. And the reason it's open is we don't care if there's a sharp point here at the end. We don't care. That doesn't matter. If the derivative doesn't exist here at this end point, it doesn't matter. We just need it to be smooth in between the two endpoints, right? So, but we do need those endpoints to exist, so we do need the function to be continuous all the way, including the endpoints, but it only needs to be smooth in between. Okay? All right, so that was that reasoning. So like 19, for example. On 19, it asks about why do you know that in the interval -1 to 1, there needs to be some point that has a slope of 2. What did you do to work that out or show that?
Do the average.
Yeah, I think the key to a mean value theorem problem is you really start over here, right? You start over here. So what you needed to do there is not just do the slope and set it equal to 2, right? If you just did the slope and set it equal to 2 and found a point between -1 and 1 that equaled that, that's not enough, right? That's not enough, because all you did is find out that there was a slope in there that had equal 2. What you didn't do was this part of it, right? The reason there has to be a point in there that has a slope 2 is the slope between the endpoints is 2. So on number 19, you needed to do this, okay, to get that right. If that was a question on the quiz, that's what the work you'd want to show. So I think when you plug a 1 in there, you get 2. You plug a -1 in there, you get -2. And so that becomes 4/2, which is 2. And so therefore, since the slope between the endpoints was 2, and it's a polynomial, which is continuous differentiable everywhere, then there has to be some point in between. And they didn't even ask you to find it, I don't think, did they?
They gave it to us. No.
Yeah, they didn't even, did they say where it was or something? They gave you the 2, but they didn't say what X value.
They just explained.
They just said, explain why there has to be a point in there that has a slope of 2, and it's because of this, right? So you needed to do that. And I know sometimes I've had people just do the derivative, set it equal to 2, and find the place where it was 2, which sometimes you have to do, right? Sometimes, like in this problem, find the value C that satisfies the mean value theorem. That's the one we did yesterday, I think. Well, plug in your 1 and your 4, find the slope between the endpoint first, then do the derivative and set it equal, okay? All right, so kind of a minor thing. And then on 33, that was the one with the speed and stuff that we talked about. But I think if you looked in the back of the book, I think there's a mistake there. I think they said he wasn't speeding or something. I don't know, maybe he didn't look it up. You're right, he is. I don't know if you looked it up or not, but it seems like in the back there's been a mistake on that one. So he's going 80 miles an hour, right? He went 100 miles in 1 1/4 hours, so he's going like 80 miles an hour. And then the fine would be whatever, like $125 or something. Would be the fine there. But so that was like that situation we talked about. Okay, what I do want to look at before we just talk about the rest of the quiz on 4.9, or actually on, 4.9, page 287. So in your homework page, there's some problems I didn't have you do. I just thought we'd talk about them right now. 15 through 18. So 15 through 18, mean value theorem. And they talk about the function absolute value of x, okay? Absolute value of x. And it says it asks some of these questions like, does it satisfy the hypothesis? Does it satisfy the conclusion? Which are some problems we did on the other theorems. I just didn't assign any of these for this one. Also, you had some homework problems that talked about the converse. They talked about if, then, true, false. So you can expect to maybe have some of those kind of problems, some true, false kind of things, as it applies to the different topics we've had here in chapter 4. Okay? As those were. Okay, so on 15, does this function satisfy the hypothesis for this, the mean value theorem from -1 to 2? Does it satisfy the hypothesis? No, because the hypothesis is it's got to be continuous and differentiable. Well, clearly between there, it is not. It is, the derivative doesn't exist right there at 0. So no, it does not. 16, does F satisfy the conclusion? Now it might, right? I mean, you might get even if you don't get the A, you might still get the car, right? So even though the hypothesis is not satisfied, it might. Well, does it? Well, here would be, so if you were going to explain why, you would probably calculate that slope, right? What is that slope? It goes up 1, because that'd be 2, 2. It goes up 1 and over 3. So that slope would be 1/3. There is no point in between there because these slopes are -1 and these slopes are 1. So there is no slope in between there, or there is no point in between there that has a slope of 1/3. So it does not satisfy the conclusion. Could have, but it didn't. All right. 17. Is the hypothesis satisfied between 1 and 2? Yes, it's continuous, it's differentiable. So yes, it does. Does it satisfy the conclusion? Well, better, right? I mean, if it satisfies the hypothesis, it has to, right? It's a theorem, it's a proven theorem, it's got to be true. It's kind of like the promise, if you get an A, I'll buy you a car, assuming that your parents are liars, right? If you get an A, you have to get the car. If it does satisfy the hypothesis, if it's differentiable and continuous, then it has to satisfy the conclusion. And then it says, well, find at least one value. Well, okay, the slope between the endpoints is 1. Find one point that's got a slope of 1. 1.5. Now, the only trick to that is make sure it be in between. Because it does say in the mean value theorem that it's got to be in the open interval. So the C has to be between the endpoints. So don't say 1, don't say 2, but any point in between would be fine. And how many are there would be infinite. Okay? All right. Yes?
When we were doing number 16, could technically the point where it's identified that sharp point, does it? Like, could it technically have like that slope where it's undefined, or how does that exactly work?
It's undefined means there is no slope. In other words, you're right. When you have a sharp point, it's like, what would the tangent line be? Would it be there? Would it be there? Would it be there? I mean, is that what you're getting at?
Yeah, like it could be anything.
No, I don't think that's what undefined means as much as, because it can't be all those values, right? And it just, so there isn't one. Yeah. So by definition of a tangent line there, I mean, I guess you're right. Like a tangent line in a circle just means it touches in one point, right? So all these different lines, I suppose you could technically say are tangent lines in the sense that they touch that curve at one point, but not as it relates to slope.
Okay.
On 18, the last question was how many sets C's exist. In between those, would it just be infinite?
It'd be infinite. It'd be infinite. Here, let me go back, Matthias, to what you said, because here, remember, to really understand that, I think we would have to go back to the formal definition of derivative. And so we would have to do this. And we would look at that. And if you picked a point and then picked another point and they got closer and closer and closer and closer together, for the derivative to exist here, those slopes, those values would have to be getting closer and closer and approaching something, and they don't. Because on this side it's 1 and it's 1 and it's 1 and it's 1. Like if you did 0 and it's 1 and it's 1 and it's 1 and it's 1 and it's 1, and then all of a sudden it's nothing. And especially if you pick the point over here and over here, right? It's negative. It never approaches something. So that's why by the definition of what slope is, the slope can't exist at that sharp point because it's not approaching something. When you have a smooth curve and you take 2 points and they get closer and closer and closer together, that slope just keeps zeroing or narrowing in and approaching about. And that's why. So it does come back to the definition. Okay? All right. Anything else? All right. So let me just talk quickly while we're on this. If you just turn the page to page 288, 289, on chapter 4, it's got a nice summary. Not all the chapters kind of have this, but in this chapter, we're kind of wrapping up all this stuff that we've been doing all year long, kind of using the derivative and how can we apply it, what are some various things we can do. So the quiz, the test is gonna have a lot of things, will just be a lot like short answer, true, false, state the three theorems, obviously. Some of these questions we've done with the extreme value theorem and stuff. But there was some other stuff in the chapter, so just to remind you, this isn't a bad page just to look at to help you with that. Like, for example, slope fields, okay? We did slope fields, that was before Christmas. Not gonna have you draw any slope fields or anything, but just maybe be able to answer a question about what they are, right? Slope field says right in there is a graphical solution to a differential equation. Another question could be, what is the solution to a differential equation? Well,
The
no,
original equation.
the original equation. Right now, a slope field is just a picture of the original equation, but it's the original equation. And a differential equation is an equation with derivatives, right? That kind of stuff. So just basic kind of questions. The next one, L'Hopital's rule or limits. Not going to have you solve any limits or anything, but could ask you about L'Hopital's rule, right? Derivative top, derivative bottom. You use it when it's 0 over 0 or infinity over infinity, right? So it could be something involving that. Optimization. Finding max min, right? Where do you look for max min? Derivative is 0, derivative is undefined, endpoints, right? Critical points is in bold there. What's a critical point, right? Well, derivative 0 or derivative undefined. What's a stationary point? It's where the derivative is 0, right? Just so there could be some things about terminology, that kind of stuff. Parametrics, don't worry about that. Related rates, don't worry about that. Those were problems we actually had to solve. Linear approximation, that's not even a section we did, so we skipped that. Newton's method, right, describing, I said, talk about the process, writing the tangent line, or what are some things that could go wrong, like the cycling thing, or the shallow tangent, which shoots you way off to somewhere away from a road or something like that. But a lot of it is going to be this last thing, the continuity and differentiability. The three theorems, be able to state those, and then also have some questions about those. Probably half of it is about that stuff, if that wasn't there. Okay, so that's just kind of a overview of those things. Okay, I forgot to record that part of the other place. So I thought